In this section, we're going to take a look at add-ins and plugins that make our unit testing journey easier. So first of all, let's ask, what prevents us from running or writing our unit tests? A lot of times we think about doing test-first design, and we start with a grand idea of writing unit tests, but then we find after a few months, we're not writing unit tests anymore, we're just writing code. And we're writing untested code, which means we're increasing our technical debt. So what prevents us from running and writing unit tests? First of all, we might say, I can't test this class because it has too many dependencies. Well, for that, we're going to take a look at Mockito, which allows us to mock out dependencies. So when we're writing a unit test for a class, we're literally writing the unit test only for that class, and we don't have to concern ourselves with dependencies. Secondly, maybe we don't know what our unit tests are covering and what they're not covering. And for that, we're going to take a look at code coverage, which fortunately is automatically built into Android Studio. In Eclipse and some other IDEs, you can use a plugin called Ecolemma, which does a great job of showing code coverage, but in Android Studio, we have this automatically. The next thing is, sometimes we just forget to run them. And after maybe 2-3 weeks of forgetting to run our unit tests, we find that our unit tests are out of date because we simply have not maintained them. So we need a way to remember to run them. And what we're going to do is we're going to set up a run configuration that will run them automatically anytime we run or debug our application. So in this video, we'll take a look at the first item, which is what is Mockito. So our objective for Mockito is to describe what Mockito is, what dependencies it has, what is mocking an object. And to understand how Mockito works, it kind of helps to know a little bit about generics. So we'll take a look at generics, then we'll consider how to verify that a method was called with a certain parameter list. We'll look at a different flavor of Mockito, which is called spying, and then we'll take a look at a few advanced topics as well. So first of all, what is Mockito? It is a plugin that we can use to mock out dependencies. In other words, think about our plant DAO that we created earlier. We know that a plant DAO is going to receive a stream of text data in JSON format, and it's going to parse that out and create a series of DTOs, or data transfer objects, which we might also call value objects or Java beans or things like that. This plant DAO has a dependency on a network DAO, which is actually going to call across a network and get a set of JSON data from a web service. But really, we want to take that dependency away. We don't want to have to worry about all the intricacies of a network DAO when we're testing our plant DAO. And why is that? Because we've written an entirely separate JUnit test for the network DAO. We'll let that worry about how the network DAO works. When we're testing the plant DAO, we only want to test the plant DAO. So a mocked object is kind of similar to the stub classes, the plant DAO stub, that we created in an earlier volume in an earlier section of this course. A mocked object also simplifies writing test first, because when we're writing our test against maybe a DAO or a view layer or a service layer object, it might be the case that all of the dependent objects might not yet be finished. Maybe somebody else is developing those, and if we really want to do test-first design, we don't want to have a dependency on somebody else finishing a class that we're dependent on before we write our tests. So we can mock out those dependencies before the actual classes are created. One interesting use of Mockito specifically within Android is think about what an Android app is. We have a lot of things that are core Java or common Java, but then we also have things that are Android specific, like the concept of context, also parcelable. We can use Mockito to mock these things out. We can use Mockito to essentially stand in place of the Android framework. We'll take a look at some other instrumentation tests that give us another option for dealing with Android's their API. We can take a look at some other options with that in instrumentation tests, which we'll see in a later set of videos. We will use Mockito or mocked objects a lot of times when we're looking at a data source, because sometimes we want a predictable set of data against which we can run our tests. So we want to know that if we're going to run our test, we're going to have, say, in my case, several red oaks available or eastern redbuds or something like that. So Mockito is not part of JUnit 4, but they work well together. A lot of times we'll see a good JUnit 4 test will be written by using Mockito. So what dependencies do we have? In the build.gradle file, we need to add this test compile dependency, which I've provided here. Just a simple copy and paste of that into the build.gradle under the app module. Now within our test class, we can do a static import of org.mockito.mockito. ***, and that essentially gives us access to all of the static methods of that Mockito class. There are a few things we can't do with Mockito. We can't mock an anonymous inner class, we can't mock a primitive type like an int or a double, and we cannot mock a final type, which can't be changed. But to be honest, one of the things we're thinking about with this test first design is that designing for test is designing a better program anyway. We know that designing for test means minimizing our if tests. Designing for test means better object-oriented design. And if we say we can't mock an anonymous inner class, maybe we need to ask ourselves, is an anonymous inner class the right way to go? Anonymous inner classes can't be extended. We lose a lot of object-oriented benefits with anonymous inner classes. So maybe we want to think there's a better way to do this. There's a better way for test, and there's a better way for design in general. So what is a mocked object? A mocked object is essentially a stand-in for an actual object, a substitute for an actual object. With Mockito, we have a few ways that we can create a mocked object. Let's think about our plant DAO and how it is accessing a network DAO. Look at the example line that I have here where I say network DAO equals mock network DAO.class. We're not calling a constructor here, are we? We're not. What we're doing is we're passing a type to a method called mock. This method called mock is a static method defined on the class called Mockito that we imported, as we discussed, in our previous slide. Now here's where it gets really interesting. A static method provided to us by the Mockito jar. Take a look at what it's returning on this line. What it's returning is what's to the left of the equal sign. It's returning a network DAO. Now wait a minute. How can it know what a network DAO is when that's a class that I have written, not Mockito? Well, that's the magic of generics. Essentially, we're passing in a type into the mock method as a parameter. And that type is a generic identifier that tells the mock method what to return. Mockito kind of creates an object that is of type network DAO, but essentially it's undefined. The methods are not defined. We have an opportunity to define what these methods do in a predictable manner, and that is the definition of mocking an object to remove a dependency from a class that we are testing. Now, this mock method works great. Many times I use that myself. You can also use an @mock annotation. In other words, with the @mock annotation, you simply declare a variable as an attribute or a field, and then you put @mock above it. You do have to do a little extra wiring to say, hey, I want you to mock these objects. Either way works the same. Either way is fine. A lot of people prefer annotations. I tend to use the mock method, but you're going to get the same results either way. Okay, so to mock methods on an object, we have a kind of interesting syntax. It's easiest to look at the definition of the syntax first, and then look at a few examples. So we'll start with the Mockito-provided static method called when, and we're also going to use a Mockito-provided static method called thenReturn. Actually, thenReturn is not static, but nonetheless it is provided by Mockito. So what does when take? When takes the name of our mocked object, and then the method that can be called on that mocked object with a series of parameters. And what we're saying is, when this method is called with these parameters, then return some static text. Then return some kind of value, whatever the value might be. It could be an object, could be a primitive, could be text. In our case, it's going to be text because we're mocking out a JSON feed. So let's look at these examples below. When network DAO, remember what network DAO is? That is the mocked object I created in the last slide. When network DAO.fetch So we're calling the fetch method that I've defined on network DAO. I'm passing in the string called redbud. Then return, and here I have JSON in quotes. I'm actually going to put a literal JSON string in there, in other words, something that can be parsed. That would look ugly on the slide because that's going to be quite a bit of text. So I've just shortened that down to just simply JSON. But when we actually implement this, I'm going to put a real JSON string in there. So that's one way we can do it. Now, this assumes that we're calling this method specifically with the parameter redbud. But we can use that hamcrest style syntax as well. Take a look at the second example. When network.dao.fetch, and then we say any, within any string.class. So when we pass any string to the fetch method, then return what? Okay, once again, we could return some kind of JSON stream of some type. So the first example is fairly restrictive because we're saying I want to see exactly the word redbud. The second example is a bit more general. We're saying any string whatsoever, doesn't matter what it is, I'm going to return some JSON feed. Okay? So where we see that hamcrest style any syntax, there are several variants of that. We could say any int. So maybe it's a case where we have a method with a parameter list. One of those parameters is a flag, and the flag is irrelevant for the test that we're running. So we just say, you know what? I don't care what the flag is. I'm going to return this set of data regardless. Okay. We could also, instead of doing a then return, we could also do a then throw. So maybe if we pass in data that's invalid, like an empty string or a negative int or something that's invalid, in that case, we want this mocked object to throw an exception. Now I have to reinforce, this is not the class that we're testing. This is a dependency of the class that we're testing. This mocked object is something that the class that we're testing depends on. And we're simply mocking it out so that we don't have to worry about that dependency, which might not even be created in real life yet, but this mocked object allows us to go ahead and write our test against it. Okay, so one benefit of Mockito is not only can we mock out these dependent objects, but we can also verify that methods were called with a certain parameter list. Because when we call methods on a mocked object, it is going to record essentially what method was called, how many times was it called, and with which parameters was it called. So a few examples. Verify that with our plant DAO, fetch plants was called exactly one time with the word redbud. Verify with our plant DAO that a minimum 3 times fetch plants was called with any string. So once again, the first example, you see a very specific parameter, redbud. The second example, we're saying we just want to make sure it was called at least 3 times with any string. We don't care what the string was. Now, in this case, you see I'm using plant DAO. Actually, it would probably be better to do an example with network DAO on these first couple examples, simply because we're verifying against our mocked object which methods were called. So the third line here, I have a better example, which is showing a call against network DAO. In this case, we're saying verify that network DAO's fetch method was called with the parameter wikipedia.org and verify that that was called at least one time. So it's a little tricky to read it because you see we have the verify method, we have the mocked object that we're validating against, then we have how many times a method was called, then after that we have the method that we're counting, which in my case on line 3 is the method called fetch, and then we're having whatever parameter was passed into this method when it was called. So on the third bullet point example, where we have wikipedia.org, if I had some other website there, if I had Google or something like that, that wouldn't count towards this at least once. We're verifying that the fetch method is called at least once with this specific parameter. There are several other variants of this at least once. We have at most. Make sure it wasn't called too many times. Make sure we're not hitting a method excessively. Maybe 1,000 times we shouldn't be hitting the database from one DAO. At least once, at least a certain number of times, never. Make sure the method is never called with these certain parameters. So what we're doing with this verify method is we're testing some behavior. We're verifying a call to a method on a mocked object and its parameters, but we're not really looking inside of what that method does because this is our mocked object anyway. We don't care what's happening inside that mocked object. That's going to be tested by an entirely different test. Hence the definition of unit testing, testing one unit at a time. There is an alternative to mocking, which is spy, and in that case, instead of actually creating a mocked object, you're using a real object with real methods, but you have the advantage of saying, okay, I want to use this real class that I've created at some point. I'm only going to mock the methods that I require. That has a slightly different syntax because just to avoid getting some exceptions in some cases, we have to put things in a kind of funny order. So do return value. What's our return? When our spied object is called with this method with these arguments. So the order is a little bit funny because we have to define what the return value is first. Next, and we do that with the do return method. Next, we use the when method to say which spied object are we going to be using. Finally, we use the method called, incidentally, method, to say this is the method that I'm calling with these arguments. So a little different syntax, but the advantage there is if you want to mock a very complex object and you don't want to have to rewrite every single method, you just want to mock out a few methods, you can use that object and then you can use this do return when and then .method syntax just to mock the methods that you wish to mock. For example, you might not need to mock a toString method. Don't worry about that. Okay, just go ahead and use the actual object, use the toString, only mock out the methods you need to mock. Don't worry about mocking out the toString methods. Inject mocks. This allows us to do a bit of automatic dependency injection with mocking. It's useful with @spy and @mock as well. This is a little kind of advanced annotation that I haven't used much myself, but nonetheless it gives you the benefit of spying or mocking and a bit of dependency injection. If you've used Spring before, that probably sounds a bit familiar. So we have a few advanced mocking options as well. There are some things called answer, return value, mock settings, and then @runWith. Okay, some best practices. Don't mock classes that you don't own. So in other words, we want to think about mocking things like our network DAO, although we take a little bit of poetic license here because we know that we can mock Android SDK classes, or we can just use an instrumentation test, which we'll talk about in a little bit. Don't mock a value object or DTO. There's really no need for that because a value object or DTO is a set of attributes and getters and setters. That's something that is going to transfer data across layers from the DAO layer to the service layer to the UI layer. So that's something that we don't really need to mock because it's quite simple. If we find we're mocking that, we might have put too much stuff in our DTO that is not truly a DTO, not truly a getter setter. And then we don't need to mock everything. We certainly want to have our test itself. We want to test the class that we're testing. Mocks should just be used to mock out those dependencies that would prevent us from doing a true unit test. So that's an overview of Mockito.